Hello class, welcome to our elementary statistics class. This page just shows you the cover of our textbook. It's 13th elementary statistics. Don't buy the wrong book. It's 13th edition and the ebook is also okay for our class. Okay, before we start our new topics, let's just talk about why we should learn something about statistics. We already know our world is a big data world, and statistics is just the science of understanding data. It will help us to understand the data, to describe the data. So no matter what kind of job you will have in the future, it's always helpful to learn something about statistics because it will help you make a better decision. Okay, so everyone choose to learn this course is really a good choice. So let's start with chapter 2. In this chapter, we will focus on one table and one graph. In the first section, we will talk about the frequency distribution. It's also called frequency table. And the next section, 2.2, we will talk about one of the most important graphs in statistics, which is called histograms. Okay, so why we should learn table and graphs? Because when we have large data sets, we have lots of numbers, and we want to learn the general information of this data set. So it's very helpful to use the table or graph to help us summarizing the data. So let's talk about the frequency distribution. How can frequency distribution help us to understand the shape, the natural of a data set? This is an example of frequency distribution. So you see it's just a table. So it's also called frequency table. So in this table, you will find there are two columns, right? The first column, we have several classes or categories. So if we check the left column, we have 75 to 124. This is our first category. So we have total 5 categories. And another column, the right column, called frequency. This column just shows you how many data fall in the class. So there are 2 columns in our frequency table. Before we learn how to construct a frequency table, we learn some basic definitions first. So first definition, we call it lower class limits. Just like I said, we have lots of classes in our first column. And for the first class, we have the lower class limit. And the higher number, we call it upper class limits. So each class, we will have a lower class limit and an upper class limits. If we have 5 classes in total, we will have 5 lower class limits and 5 upper class limits. So if we go back to check the example of frequency table, so in the first class, 75 is our lower class limit and 124. is our upper class limit. Similarly, for the second class, 125 is our lower class limit, and 174 is our upper class limit. After that, we will have another definition, class boundaries. We will talk about this one a little bit later. Let's move on to the next one. Class midpoints. So let's check the definition first. It's the values in the middle of the classes. And how can we get it? We just adding the lower limit to the upper limit and dividing the sum by 2. So this is called class midpoints. So if we go back to check the first class of our example, we already know 75 is our lower limit and 124 is our upper limit. So we need to get the sum of these two limits, then divide the sum by 2. So we can get the class midpoint. Okay, so here we will get, what's the number? Alright, I got my calculator. So the answer is 99.5. This is how we get the class midpoints. So if we have 5 classes, then we can get 5 class midpoints. Okay, make sure you have your calculator with you because in our class we will need the calculator. Alright, next we have another definition which is called class width. Make sure you pay attention to this definition because lots of students make mistakes of this one. Let's check the definition. It is the difference between two consecutive lower class limits. Make sure you know it's the difference between two consecutive lower class limits. So if you go back to check the example, we know the first lower limit is 75. Then the second lower limit is 125. So by the definition, we should know we can get the class width is 125 minus 75. So it will be 50 is our class width. But lots of students do like that way. They use the upper limit minus lower limit to get the class width, which is incorrect. It should be the difference between two consecutive lower limits. Make sure you don't make the mistake, okay? So we have one left, which is called class boundary. So the class boundary, let's check the definition. It says the numbers used to separate the classes, but without the gaps created by class limits. Let's see what does that mean. So class boundaries can help us separate the classes. So if we go back to check this example, we have several classes. Of course, each classes can be separated, but the definition of a boundary says without the gaps. if we check the upper limit and the lower limit of two consecutive classes, we will find in the first class, the upper limit is 124 and the lower limit of 125 is not the same number. Of course, it cannot be the same number. But if they are not the same number, that means there is a gap. Right? There is a gap. So the boundary should without the gap. So how can we find the boundary? We just set the midpoint of these two numbers. So the midpoint of this 124 and 125, it will be 124.5. So how can we get to the midpoint of these two numbers? We add them up, divided by 2. We can get the middle way. Okay, similarly, we can find the midpoint between 174 and 175. It will be 174.5. Okay, and 224.5 for next boundary. And similarly, we have 274.5. Okay, and the last one will be 32.5. But we still have missed one. It's the first one. It should be 74.5. So make sure you know if we have 5 classes, you check here, but we have 6 boundaries. So maybe you just wonder why we should have the boundaries. Why we should set boundaries? Because we already can separate the classes by the upper limit and lower limit. Because when we need to draw the histogram, you will use the boundaries to help us to draw the histogram. So that's why we need to learn the boundaries. But make sure you know we have 5 classes, then we have 6 boundaries. Okay. So now we should learn how to construct a frequency distribution. First step, we need to select a number of classes. So in our example, we have 5 classes. Most of the time, we just pick a number from 5 to 20. If we do not have lots of values, basically we will just pick 5, 6, something like that. Next step, we should calculate the class width. So remember, how can we get to the class width? And if we want to calculate the class width, we use this formula. If we have a data set, we need to find which one is the greatest value and which one is the smallest value. So we find the difference between the maximum value and the minimum value, then divided by the number of classes. We defined the number of classes. So just like I said, basically it's 5, 6, something like that. And we always round our class width to a convenient number. So it will easy to get the table, right? Then we can pick the first lower class limit. We can just use the minimum value or any convenient value even smaller than the minimum value. But make sure it should be smaller than the minimum value, because if you pick the first lower class limit greater than minimum value, then your minimum value will be excluded in this class. Then we're missing some value. After that, we will use the first lower limit and class width. We can list the other lower class limits. We will list, because if we have the first lower class limit and we add the class width, we can get the second lower limit. If we have second, then we add the class width to get the third, and so on. And we list all the lower limits in a column, then determine the upper limits to finish the first column. Then we will check another column. We can just count the number of the values to finish the second column. How many values fall in this class? So let's check this example. Let's check this example. We will use this data set to construct a histogram, construct the frequency table. So this table just shows you the service time of McDonald's lunch. And the data was not be sorted. So first, we should sort our data if we want, because we will need the minimum value and the maximum value to do lots of work, right? So we should sort our data. So first step, remember, we should pick the number of classes. Because we do not have lots of values, we just pick 5 as our number of classes. So we will have 5 classes in our frequency table. Then step 2, we will try to calculate the class width. So how can we get the class width? We check this formula. After we sorted our table, sorted our value, we will find 308 is our maximum value and 83 is our minimum value. So we use 308 minus 83 divided by 5. How can we get 5? 5 is from the first step. 5 is our number of classes. So we get 45 as our class width. It's totally fine to just use 45 as our class width. Here, the example shows pick another convenient number, 50, but it's still fine to just use 45. Step 3. We need to pick the first lower limit, right? Because, we can just directly use the minimum value 83 as the first lower limit. Of course, we can also pick a number even smaller than 83. So here, the example, pick 75. Of course, you can pick 83 or 80. That's totally fine. It's up to you. Now we should define the other lower limits, right? Because we set 75 as our first lower limit. And how can we get our second lower limit? We just use the first one plus class width. We can get the second one. and so on. We plus 50 to get the third, and plus 50 to get the fourth and the fifth. So we get all of the lower class limits. Next step, we should list all the lower limits in a column. So you will check like this way. Okay, after that, we already have all of the lower limits. We still need to define what's the upper limit. Then we can use the next lower limit here. It's 125. So we will set this one will be 124 because we cannot use the same number. You can think about it, why we should not use the same number. And similarly, we can finish all of the upper limit. Why we cannot just use the same number as the upper limit and the next lower limit? Because if we have one value is just equal to 125, if these two are the same number, so what should I thought the value 125? It should be in the first class or in the second class. So just avoid the double counting. The lower limit and the next upper limit. The upper limit and the next lower limit cannot be the same value. So it will be a gap. And step 6, we need to finish our frequency table. So we need to get the frequency column. If we go back to check the original values, we will count. There are 11 values in the first class. So we can use tally marks, any way you want to count how many values in each class. Then we fill in the second column. We finish our frequency table. Of course, we have another transformation of frequency table, which is called a relative frequency table. So it is just the same as the frequency table, but we do not use frequency. This time we use relative frequency to replace frequency. But the first column, we just do the same thing. But for the second column, for each class, we do not use frequency. We use frequency for each class, then divided by the sum of all frequency. After that, we can get a percentage. Okay. It's just a transform. Why sometimes we do not use frequency, we pick relative frequency? Because we can compare two